Today we're going to continue talking about hot and cold particles. And these are some of the things we're going to talk about in this video. The particle theory of matter, heat, and states of matter. So first we're going to talk about the particle theory of matter. And from now on, we're just going to refer to it as the particle theory. Here are the elements that make up the particle theory. All matter is made up of invisible particles. All particles have space between them. Particles are moving at all times. And this is a bit tricky to remember because we think of a solid object and it's hard to imagine those particles are still moving because the object is so solid. But particles are moving all the time. An increase in heat equals an increase in the movement between particles. And there is an attraction between particles. Depending on how much heat energy they have determines their level of attraction. Alright, so heat, as we've already learned, is the transfer of heat energy from the particles of a warm object to the particles of a cooler object. So the warmer an object is, the faster the particles are moving, the more they rotate around each other and spread out from each other. The cooler the object, the slower they move. So here's a little diagram. We have our cool particle, who's kind of hanging out, but he's still moving. And we have our warm particle. And it bounces against the cool particle, and there's a transfer of heat energy. So the warm heat energy transfers from the warm particle to the cool particle. Heat is always a transfer from warm to cool. So if you want to imagine, like you saw in your video, if I put my hand on a window and I hold it there for a minute and then I take my hand away, that section of the window is going to stay warmer for a little bit because the heat energy from the particles in my hand have transferred to the window. So it's always from the particles from a warm object to the particles of a cool object. Now the states of matter. There are three states of matter: solid, liquid, and gas. And I'm going to go into some details about those different states. Solid. So solid has a fixed shape and a fixed volume. You know, it's a solid, so it keeps that shape and its shape doesn't change. There is limited movement between the particles. Now remember, the particles are always moving, it's very limited. It's a very small amount of movement. And they're really close together. There's not a lot of space in between the particles. And there's a high attraction. These particles want to be close together, they want to stay tight to each other, and that's why there's so limited movement. So there's just a diagram. So here's my particles of my solid. They're moving just a little bit, but they're really right up close to each other. Liquid. Liquid has a fixed volume, but a varied shape. Liquid takes the shape of the container that it's in. An example would be you pour water into a glass. The water will take the shape of the glass. If you then take the water and pour it into a bowl, it will take the shape of the bowl. If you then take the bowl and pour the water onto the table, the water will spread out because it's trying to find that shape to contain it. So liquid has a fixed volume but a varied shape because it changes its shape depending on the container that it's in. There's some movement between the particles, so there's more space between them. They're rotating, they're moving past each other, they're vibrating, and there's some attraction. Not as much as in the solid. They don't want to be right close to each other, but they still want to be near each other, so they don't move too far away from each other, but there is more movement and less attraction. Gas. Gas has no fixed volume and no fixed shape. There is lots of movement and very limited attraction. These particles want to be as far apart from each other as possible. They're twisting, they're rotating, they're vibrating, and they're spreading apart, which is why they have no fixed volume and no fixed shape. They will continue to move as far as they're allowed to. And they don't want to be close to each other. So there's lots of space between them, and they're moving constantly. So thermal energy, to go back to our definitions video. Thermal energy is, remember, the kinetic energy and the level of attraction in an object. So thermal energy, that heat energy. The more heat in a particle, the faster it moves, the more it moves. Which makes its kinetic energy, right? And the energy of all moving things, and all particles are moving. The level of attraction is determined by how much kinetic energy something has. So when we think about the heat heat energy in a gas, there's very little attraction. It's spread out all over the place. But in a solid, there's lots of attraction and very limited kinetic energy because the particles are not moving a great deal. So those two things together make thermal energy. You can increase the thermal energy by heating an object, or you can decrease the thermal energy by cooling an object.